Hi, everyone. Good day, and welcome to webinar 6 of our 9-part webinar series on wind energy and wildlife. Today's webinar is on communicating results. A couple of housekeeping notes that we bring up at the beginning of each webinar. Everybody will be muted on the webinar. If you're having audio issues with your computer, you may want to try calling in with your phone. Any other support questions, you can visit the GoTo support website or call the toll-free number listed on the screen. This webinar and all of the webinars in the series discuss, complicated issues that have different perspectives, different stakeholder interests. And so we ask that everybody assume positive intent of our speakers. We want you to be actively engaged. We have a couple of trivia questions to kind of break up the conversation. So please weigh in on those when they come up. And also, if all goes as planned, we'll have time for Q&A towards the end. And you can ask questions using the Q&A feature for the GoTo meeting. Just a reminder, the Tethys website is a great resource for literature review. There's also an events calendar, and you can sign up for Tethys Blasts, which are a biweekly newsletter that gives you the latest and greatest on new reports, publications, events, webinars, conferences, and such. And on Tethys, we finally had a chance to post our first 5 webinars. The links are provided here on this page, but you can also find them by looking at the events calendar and clicking on the links there. We are, I think, once we get all of the webinars on Tethys, we'll have a more have them all on one page so you don't have to go through that search process. Next week is webinar 7 on the 22nd from 1:30 to 3 Eastern, and then we'll have 2 more webinars after that. We're still working with our speakers to set the day and time. And with that, it's my pleasure to introduce today's speakers for this webinar. We have Goni Iskali from who is an environmental permitting manager for Apex Clean Energy. Manuela Huso is a research statistician at the U.S. Geological Survey, Forest and Rangeland Ecosystem Science Center, and Julia Garvin, who is a senior ecologist and project manager at Tetra Tech. And so before I hand it off to our distinguished speakers, I just want to give a quick overview about communicating results. I think we all appreciate that it's an essential part of having a successful project. It should begin as early as possible and continue often throughout the study. It helps build trust among the project partners and promotes efficiency, making sure everybody is on the same page. And it also relays important information to make decisions from. And really the end goal of any project and for the communication aspect of the project is having the publicly available report so that the broader wind wildlife community can use that along with other data to make informed decisions. There's a lot of behind the scenes communication with any project among the project team and partners for the study. What we're going to focus on today, though, is communicating the results to the broader audience. So through technical reports, publications, presentations, and webinars. And in order to do this, you have to be able to convey the methodology you use, the statistical analysis, and In our previous webinars on grouse, bats, and eagles, we talked a lot about the methodology used to study wind-wildlife interactions. But for today's conversation, at least in part, we're going to talk about the statistical analysis. And Manuela is going to give an overview of the Generalized Mortality Estimator and evidence of absence statistics and tools. And then Goni and Julie are going to talk, give their perspectives on estimating mortality. And then we'll spend time talking about, with our panel, the key aspects of good reporting. And so with that, I'll hand it over to Manuela for her presentation.
All right. Well, thank you, Chris. Can everyone see my screen?
Yes.
All right. I can't. Yeah, thank you very much, Chris and NREL, for inviting me to talk to you today about GenEst and EOA, and then in that context, communicating the results that they present you. I want to give first a really big shout out to Dan Dowthorpe, who's kind of the mastermind behind GenEst and evidence of absence, as well as our co-authors for those two softwares, the supporters that we had both in agencies and in through funding and through agency help, and then a whole list of people that helped through reviewing and all kinds of ways in making them happen. I have to give a disclaimer to start with that what I'm presenting today right now has not been peer reviewed, and so it doesn't have the full backing of the USGS behind it. So when you're looking at a big pile of data that you've collected in post-construction monitoring, you might be starting out by asking yourself, which estimator do I use? You might think about the naive one. It's pretty easy to calculate, but it doesn't have any way of calculating confidence intervals in it, and it's actually not a very good estimator. The Schoenfeld's is more complicated. Again, it doesn't have software associated with it, so it's you would have to be on your own to calculate the confidence intervals around it. What people call the Housekeeping estimator does have software in the USGS publication DS729 and does give confidence intervals. Korner-Nievergelt is a R package called Carcass, and the Wolpert estimator is in an R package called ACME. Evidence of absence is also in an R package called EOA. So all of those have basically do the calculations for you so that you don't have to calculate these kind of hairy looking equations. And the last three give you, including EOA, the fourth, give you confidence intervals, which you'll see is really important to me and to accurate representation of your results. But I would argue that this isn't really the first question to start with. The best question to start with is, what do I want to know? Am I facing kind of a regulatory condition where I'm looking at a single species and want to know what's the likelihood that I am actually below some set threshold? Or am I in a more general context where I'm looking at to see what the impact of mortality or impact of wind facilities is on wildlife mortality? And I'm interested in just a general estimate of mortality for groups of species and confidence intervals over a fixed period of time. If I'm in the first case with a single species of interest, then chances are really good that EOA is going to help you. If you're in the second case, then chances are really good that GenEst is going to help you. So I'm going to talk about each of those, and then following a brief description of each and what it can do for you, I'm going to talk about some of the things that I would like to see, or I would suggest that people put into reports. And of course, that's my opinion. But before we get there, I want to start with a trivia question. It's in the EOA context, but let's say that at a particular facility, 5 Indiana bats were killed in a given year. And the post-construction monitoring was such that it resulted in a G, or a detection rate, of about 1 in 6 bats being detectable or being detected on average. So I want to ask you, just quick gestalts, what's the chance of missing all 5 of those Indiana bats? 10, 20, 30, 40, 50%. If you guys will just take that poll, that'll be great. And we will summarize the results in just a few more slides. So I'm going to give you a few seconds to just quickly say off the top of your head what you think the probability is of missing all 5 of those Indiana bats when you have a 1 in 6 chance of finding any of them. Chris, you can tell me when to move on. Are you ready, Chris? Shall I move? I don't hear you.
Sorry, I had muted myself in 2 different places. Yeah, you can go ahead, Manuel.
Okay. All right. So why do you use EOA for a single species? Well, because it gives you a really good idea of how many of that species you might have missed when you were doing your searching. In this example, I set the credibility level at 50% with a site detection probability of 1 in 6, kind of like the same example that we just had. And in this case, we observed 3 carcasses. You can see right at the top there, we've got a 100% chance that our mortality is greater than or equal to 3 because we found 3 over the last 4 years. It also tells you then that you have a 50-50 chance that the mortality at the site during that time was somewhere less than 13, somewhere between 3 and 13. Really importantly, in most cases, when we're talking about regulatory issues and we're talking about managing over a series of years, we want to know what kind of underlying mortality rate might one expect at this site. And so EOA gives you that estimate. You might alternatively want to know not what the sort of the max was, but what's the best 50% interval or 95% interval, whatever you want. In this case, EOA estimates somewhere between 8 and 18 carcasses that were likely, I don't know, got a 50-50 chance that the true number is within that bracket. In addition, EOA does its best to look out into the future for you. Here we have a projection that is one of the visualizations that comes out of EOA. Down at the lower corner are the 4 years that we've already monitored, and we have data from them. So those are estimates of what might have happened during that period. But then we take that and we project it into the future. If things go as they have, and as you suggest they will, that is, you say what your monitoring is going to look like, you say what your adaptive management rates, effectiveness might be, and then EOA will take that and predict where you're likely to be in 10 or 20 or 30 years, whatever you choose. In this situation, the one we're looking at, it looks like the take limit was set at about 40 over 20 years, so 2 per year. And that out at the far right, maybe at the end of those 20 years, we have a little bit higher chance that we're going to be above it than we are below it. But that's a long ways from now. This is just giving you an indication that given what you know right now, you probably don't have a whole lot to worry about. You're pretty much on target. Another tool that EOA has is a design module to help you minimize costs when you're trying to achieve a particular G. That G is usually arrived at from discussions with all kinds of stakeholders and parties. And typically what we're trying to do is be able to say at the end of the day that after having found 0 or 1 or 2, we can interpret that 0, 1 or 2 like endangered species or species of concern. We can interpret that. If we had a 90% probability of finding things, and we found 0, that means something. That means that maybe you missed one, but very, very unlikely that you missed 2. So you've got a good sense. If you have a detection rate of 0.1 of 10%, 0 means a lot less. It means that, yeah, it could be 0, but it could be quite a bit more, 10, 20, or 10, 15 that you might have missed. Quick return back to the trivia question. Chris, how did people respond in this? And I'll tell you the answer in a moment.
Yeah, so we had 12% respond to A, or 10%. 32% of the audience thought it was 20%. 24% of the audience thought it was 30%, and 14% of the audience thought it was 40, and then the remaining 18 thought it was 50. So really relatively evenly mixed.
Yeah, so the answer is 40. And so the 40, 50 are pretty darn close. The way we get to that is that the chance of finding one is 1 in 6, so the chance of missing one is 5 in 6. The chance of missing the second one is 5/6 times 5/6, because it's you miss the first one and you miss the second one, and in probability you multiply when you have an and. When we take that out 5 times, you've got 5/6 to the 5th, and the answer is about 40%. So with a small detection probability, the chance of missing all 5 it's less than 50-50, but it's still pretty darn high. All right, let's keep going with the evidence of absence, the design module. This graphic is something that comes out of EOA, and it shows you that kind of thick white line is the isocline for a G of 0.25. So that says on the y-axis you've got search coverage, which is the fraction of fraction of turbines searched combined with kind of the fraction of carcasses that you expect to fall within the searched area beneath the turbine. So let's say, and somewhere over here on the right, I think is kind of a sweet spot. Whoops. That's not what I meant. So let's say we had 3/4 of our turbines searched, and we also searched an area that comprised about 50% of the carcasses beneath each of those turbines. That would result in 0.75 times 0.5. That's about 35% coverage. So that's that horizontal line. If the area within that area where 50% are going to land is pretty visible, easy to search, or you're using dogs, you might be able to achieve an 85% searcher efficiency. So this tells you that with that combination of things, you can achieve your goal of a G of 0.25. Now you can vary, this is all under the context of keeping these things constant. We've set our interval at 3. We've set our best model for persistence to be to tell us that about 75% are going to persist from between the time they land and the next search. But those things can be changed too. So you can vary what your search interval is, how widely you search, how many turbines you search, whether you use dogs or not, and come up with something that is the best for you in terms of cost, but still achieve that target G. One other thing we did was work very hard with Fish and Wildlife Service in Region 3 to look at adaptive management triggers and use EOA to say when are we kind of looking like we might be getting in trouble relative to the set take. How often will those triggers that we're getting in trouble fire needlessly and fire correctly, and how do we balance that management of the species with optimization for the production of the energy. I'm not going to say much more about that, but I later give you a reference for it. How am I doing for time? Good. So I'm going to shift gears now and go to GenEst. So these are all the estimators that we showed before. And one of the things that you probably don't know but might be interested in is that pretty much all of the original authors of these estimators combined their efforts to work on GenEst. So we realized that, in fact, we could take each of those estimators and put them under a much more broad umbrella estimator that kind of comprises all of them. The data that go into so this is kind of a natural evolution of methods. It's just rather than really a new estimator, it's an estimator that comprises all the others. It didn't require very much, if any, data collection process change. We ask, rather than making assumptions, that you provide data on SE and CP and DWP so that you can choose the best models. And from it, then, we in return give you an accurate estimate of uncertainty. That means that if we say 90% confidence interval, then 90% of the time when you use that process, the true value will be within your interval. We account for pretty close to all sources of non-detection. Sometimes the most difficult one is the temporal side of things. The estimator is as unbiased as you can get when G itself is not known but has to be estimated. So by doing that and getting really close to unbiased, we can give you meaningful estimates that then, with those, then you can do all kinds of comparisons and all kinds of trend estimation and look at efficacy of mitigation. If you don't have an unbiased estimator that's on the basis of all this, then those comparisons just become really mushy. And most importantly, we give you confidence intervals. It's a point estimate, as I'll say later, and I'll say it again, is just not very useful without some sense of how precise you are in making that estimate. So speaking of coverage and being good at when we say we've got a 90% interval, we have a 90% interval. That's one of the major factors that we used when we compared GenEst with 4 other estimators. We combined resources with Paul Robbie from West and 2 others from West to compare these 5 estimators. We compared GenEst with with K parameter estimated from the data, GenEst with K assumed to be at a certain level, the Housekeeping estimator where the not fresh carcasses that didn't arrive in the preceding interval are excluded, which is what we ask for people to do. Housekeeping where you put everything in, even the old ones, which we know is going to give you kind of a biased estimate for the most part. How biased depends on how many carcasses enter that shouldn't. And then the Schoenfeld. And the only thing I want you to get out of this graph is that an ideal estimator would be right in that area. It would be a horizontal line at 0.9 because we're looking at 90% confidence interval. The GenEst estimator with K estimated enters that space at about 10% of the kinds of the simulations that we used and just stays there. So over 90% of the different simulations that were different conditions that we tried, GenEst got really close in its confidence intervals. The others vary, but what's kind of important here is that Schoenfeld didn't hit it very often. There's a lot of the situations that we simulated where it just didn't cover what it's supposed to cover. I want you to know that we tried really hard to break it, so we don't expect our estimators to be perfect all the time. Down here, we're talking about maybe, for example, 10 turbines for which we only searched 30% of them with a G of 0.2, and we had an underlying rate of 1 animal per turbine. I mean, we're going to get very, very little data to work with in the first place, and the coverage is pretty poor under those conditions for any estimator. It doesn't matter. Okay. Another question that's arisen is, how does GenEst compare to EOA? So I calculated 90% confidence intervals for both of those, EOA and GenEst, 2-sided, and a 50% two-sided confidence intervals for both of them under different conditions. How many found was ranged from 0 to 5, and the detection rate was very low at 0.1 and then pretty moderate at 0.3. But I don't know of too many people who like looking at tables, so I made this into a graphic that might be a little bit easier to see. What I think you should get out of this is that they're pretty close. They're pretty darn close. They're right, but they're not exactly the same. Julie pointed out that the GenEst estimate tends to be a little bit towards the left, a little bit smaller than the evidence of absence. But we know that the GenEst under these small conditions, these conditions where we see very few carcasses, tends to not cover as well as it should. So under these conditions, you probably would be better off using evidence of absence, although the advantage isn't great. So question number 2, trivia question. We're at a different site, 5 Indiana bats were killed, but post-construction monitoring had a G of 0.63. Almost 2 out of every 3 bats would be expected to be found. What's the chance of finding all 5 of them? And I'll let you go now. We're going to just answer that question right away. So Chris, just let it go for as long as you want.
Okay. Right now we've got 25% of the vote or participants who have voted. I'll wait till it gets at least to 50%.
Okay.
Yeah, so here we have about 25% for A and B, 34% for C, and then less than 10% for both D and E.
All right. Well, that's good. It's not 50%. It's 10%. We do pretty much the same thing. The chance of finding 1 is 0.63. Of finding 2 is the product, 0.63 times 0.63. All 5 is 0.63 to the 5th. So we've got about a 10% chance of finding all 5. So even though our detection rate was pretty high for post-construction monitoring, the chance that we find all 5 of them is pretty low. Okay, I'm going to move on now to things that I see sometimes in reports and would prefer not to. Point estimates are always wrong, pretty close to almost always wrong. Sometimes if we're dealing with, counts, we might get it right accidentally. But the intervals are the ones that we should be paying attention to. So a single number with no uncertainty around it is just really not useful. Sometimes I see people take the raw data rather than the adjusted mortality estimates and try to get some inference out of that. We might see something that says, okay, the proportion of animals, of carcasses that were in each of these species groups was as represented here. So we had 16% raptors, 21% shorebirds, and 40% passerines. So from that, you might think, oh, well, that sounds like then probably we had about 2.5 times as many passerines that were killed as raptors. Well, proportion of raw counts doesn't really help you unless maybe you're trying to figure out freezer space or something, but it doesn't help you in understanding mortality because of the very different detection rates that some of these can have. So if we adjust these data by their detection rates, we get a very different picture. Now we see that in this little example, toy example, we had 8 times as many passerines that were likely to have been killed at this facility rather than 2.5 times more passerines than raptors. So the point is that proportions of raw counts are rarely very useful. We need to work on adjusted counts. If you're tempted to provide an average of searcher efficiency or carcass persistence for your site that ignores or somehow averages over your factors that might influence those, like visibility class or season or even size, please resist. A national average of searcher efficiency just isn't meaningful at an individual site. It's about as meaningful as a national average for height, weight, or IQ is to you. The sort of what this idea of averaging searcher efficiency or carcass persistence has led to is an exploration of an idea that is called integrated bias trials. And I want to show you how that might lead you down a path you don't want to go down. So here's an example. We've got a turbine with 100-meter search radius in yellow and 50-meter search radius in gray. So with that, those dimensions, 75% of the area is in the outside ring and 25% of the area is in the inside ring. For integrated trials, they typically describe it as being just kind of setting the carcasses out randomly, evenly distributed throughout the search area and throughout the time of search. And then all they do is just count what comes back and use that as an estimate. Well, let's say we set out 100 trials, and because of the area and because of that uniform distribution, 25% would be on the inside and 75% would be on the outside. But let's say also that the detection rate in the inside is much higher than in the outside because the visibility class is really good. And it's 0.8 on the inside, 0.2 on the outside. So of those 75 that were set in the outside, we're going to expect to find 20% of them, or 15. In the inside, we'll find 80% of those 25 that we put in there, so that's 20. But we won't know that, right? All we'll know when we do the integrated trials is that we found 35 of them. And so 35% is going to be our estimated G. Well, let's say that, pretty reasonable, that within 50%, or sorry, within 50 meters of the turbine, we've got half of our carcasses land there and half of our carcasses land between 50 and 100 meters. We know that density is not constant, and that's pretty reasonable estimates. So what we would really find is, of the 50 that arrive in the middle, we would find 10. Of the 50 that arrive, or sorry, in the outside, we would find 10. Of the 50 that arrive in the middle, we'd find 40. So we would find 50 carcasses, but we'd use 35% as a G, and we would estimate 143 were killed. Well, that's way over what really was killed. And it's because we have ignored factors that are very important to determining the searcher efficiency or the G in each of those categories. So the point is, you can't ignore factors when you're doing integrated trials. You still have to separate the trials based on those visibility classes or seasons. And so you have no advantage in reducing the number of trial carcasses that you need to carry out your study. In addition, you have the disadvantage in that you lose information that you can use to improve your protocol. You don't really know why those 35 weren't found. Was it because you had too long of a search interval, or was it because your searchers weren't good, or the visibility classes were too high, or what? It's like you don't know, and so you don't have any information with which to go on. So that's my little shtick on integrated trials. So a report, I think, if they give you basically some information that allows you to get a rough estimate of what each of the different detection probability, or sorry, the different factors that enter detection probability are, you should be able to calculate a rough approximation. So you should be able to take what was found, X, the number of carcasses, divide by what they say was their estimated M, and get an estimate of G. Is that reasonable? If by doing that you find out that G looks like it must have been about 0.8, but you know that they only searched half the turbines, there's no way you're going to get a G of 0.8 with by searching only half the turbines. So it just gives you a good rough approximation rule of thumb to just see what's going on. So basically include the monitoring period, oh geez, I'm a bit over, the number of turbines searched, how often, how extensively, the factors that might affect detection, and the number of trials per factor combination that you use. not just like I put out 150 trials. If I put out 150 trials, but there's 3 size classes and 3 seasons, that's 9 classes already, and 2 visibility classes in each. Now we're up to 18. 18 different factor combinations divided into 150 carcasses. That's not even 10 each. That's not enough with which to really make good estimates of either searcher efficiency or carcass persistence. And finally, of course, the number of carcasses found. So ideally, you can use some of the stuff that comes out of GenEst. Ideally, I'd like to see a table of the models that were compared for searcher efficiency and carcass persistence. And that gives me the evidence of why you chose the one you chose. I'd like to see how that model compares to the saturated model, the full model. Like if I used all my factors, where do things differ in terms of either P and K in this example, or in terms of R? I'd like to see graphics of how the different distributions for CP compare with one another and how they compare with the underlying data. That's the dark black line here. I'd like to see tables of estimated searcher efficiency and carcass persistence with confidence intervals, of course, and very importantly, how many carcasses, trial carcasses went into each of those estimates. And finally, for the total mortality, I'd like to see a table that represents the mortality and confidence intervals of the groups that are of interest. So here we've got 3 different bat groups and 2 birds and each of 3 different seasons. That's important to us. And we give how many were found. So with that, I've got plenty more that I could say, but I've run out of time, and I just wanted to give you the references that you might be interested in looking at, and say thank you for your interest.
Great, thanks, Manuela. And now we'll go to Julie. And so, Julie, take it away.
Hi there. So first, I would like to thank Chris, all the folks from NREL and Defenders of Wildlife for inviting me to be part of this webinar. So thank you. So I'm going to sort of take some of the points that Manuela was discussing, which are really sort of the state of the science, and then sort of translate how sometimes we've got to think about how the rubber meets the road when planning some of these monitoring and planning the reporting. So a lot of this is intended more at a higher level than talking about individual estimators or confidence intervals. These are just sort of lessons learned as on behalf of myself, who is a consultant and is also often working for clients who are trying to navigate this ground of performing monitoring and making the most of it. So the first point, I'd like to recommend that anyone who's considering performing some monitoring at a site, that when you're thinking about this, you want to begin with the end in mind. So that's taken straight out of Stephen Covey's 7 Habits of Highly Effective People. So you want to think about, just as Manuela mentioned, why is the monitoring being performed? Why are you going to spend this money? And mortality monitoring is not cheap. So think about why you're spending this money. What questions are you trying to ask? Have they already been answered at a site near you? In which case, can you answer a little bit different questions? Or what is important to you as an operator or the agencies or your financiers? Once you've come up with a study objective, stay focused on that as you come up with your study design. So if the study objective is to determine how many eagles were killed at the site, that answering that question is going to be very different than trying to answer a question of how many rare bats were found. The methods are not necessarily going to be the same for those 2 studies. Similarly, collect only those data that are relevant to the question being asked. It's very easy to look at templates and pre-existing report forms and just fill them out and crunch all of those numbers, but that could end up leading to a lot of wasted time and excess data that just sort of blurs the picture and gets away from the question that you're trying to answer. We all know that the best laid plans never last. Engagement with the enemy. So be sure to track the departures from this wonderful study plan that you've developed. Why the search schedules had to be changed, maybe because there was maintenance being performed, or there was icing on the blades and there was a stand down. Maybe there was some mandatory maintenance from the turbine manufacturer and the whole site was shut down for a month. That's going to affect the collision risk for that study that's happening. So be sure to track these things in real time as they go through. And don't leave data QA, QC, or quality assistance, quality assurance, and quality control to the end of your study. That I can say with much confidence is a recipe for disaster. Knowing what are some of the issues with your data collection at the beginning, and ironing those out early on will prevent data loss and will also make it easier to roll into reporting and data analysis once the study is completed. So doing those things in real time will allow you the flexibility to fix the problems as they arise, instead of realizing after the fact that you have some pretty serious data gaps. Another one to keep in mind is that when you're performing monitoring on an operational wind facility, there's lots of different people there and they all have lots of different jobs. So it's really important to clearly establish the roles and the communication procedures. So if something important is found, whose job is it to report that? Who do they need to report to? Do they need to report it to a federal agency, a state agency? How quickly does that need to be reported? What kind of data needs to be collected, and whose job is that? Is that the role of the turbine technician, or is that the role of a third-party contractor? So it's really critical to have these things laid out, ideally before the study is even implemented, so everyone knows what their job is. Next slide, please. So similar to the sort of first lesson for monitoring, I'm using the same one for reporting. As the report is being prepared, make sure to begin with the end in mind and have this report answer the question that the study is asking and stay focused on that study objective. If at the end of the report you haven't answered the question that's being asked, if you can't answer the question, you should know why it couldn't be answered. As the report is being structured, it's really important to know the audience. Is this report going to be kept for internal purposes only? Is this going to go to financiers who have other questions that they might be asking from the monitoring study? Is this going to federal or state agencies to look at? Are they going to be providing input on the report? So the answers to those questions will definitely influence what kind of report is prepared. And similarly to my caution about only collecting relevant data, similarly, you only want to present relevant data. And it's very likely that much of the data that you collected during the monitoring doesn't rise to the level of importance that it needs to be presented in the report. I would like to say that if a report is not read, there's some blame perhaps to be laid on the people who received the report, but the report author is just as responsible for making sure that the report is one that's easy to read and is going to be read by the recipient. So related to the data analysis, just as underscoring something that Manuela was saying, is show your work, just like in elementary school. Show the methods that you used, what turbine searches were missed, how did you model your data, what models did you select, and what method did you use to select those models, how did you generate your confidence intervals. Having a report that concludes, hey, we did this sort of searching, we found one dead eagle, and we think that maybe there were actually 5 killed. How do you know that? What's the level of confidence you have in that statement? That's really critically important, more so perhaps than even the number. So, and then another key factor for reporting is that the report is pretty much the only record that the monitoring occurred. So this is the first and last impression that of the study itself. So that makes it critically important if money has been spent to perform and implement a really well laid out study. Having a quality report that reflects the quality of the study is really critical. A shoddy report is going to make the reader infer that perhaps the study itself was not that well planned, and that may be very inaccurate impression. Next slide. So one of the things Manuel also talked about was some standardization, and I would also underscore that, at least in the industry, we would recommend that the fatality rates are presented per megawatt because turbine technology is changing so rapidly. That's a more appropriate metric to enable comparison rather than per turbine. And also that having a study period being accurate to the study period that was actually studied is important. So if you only studied it for 2 seasons or 3 seasons, don't provide or don't state that your estimates were for a year unless you actually did extrapolations to simulate what they would be for a year. Similarly, provide 90% confidence intervals on all of your important metrics and provide the methods for how those were generated. Another thing is that tendency is for many fatality estimates to be presented for small birds and large birds. And it's important to define those terms and how those size classes were selected so that when you have a large bird estimate and you compare it to a large bird estimate from somewhere else, that you are comparing apples to apples. Similarly, if you're going to make some comparisons, and that is really important to put the results of the study into the appropriate context. Perhaps the fatality estimate for bats was incredibly low at your project. Well, maybe it's important to mention that you are actually searching for bats only in the winter when bats were not expected to be found. And that just is similar to the next point below, which is to clarify the caveats in the comparisons. If you're taking the results of your study and you're comparing it to all of these other wind facilities in the Midwest, pardon me, you need to mention perhaps relevant factors. So if your study is in grasslands, point out that not all of the studies that you're comparing it to might be grasslands. Maybe some of them are agriculture, and that could affect the appropriateness of comparison. And then, I'm sorry. So then a really crucial piece, and this may or may not be in the report, is communicating the implications. I'm sorry, I need some more water. So this may, after conversation with the client or whoever is the person providing the funds for the study, if they may not wish to have any important implications presented in the report for various reasons, maybe depending on the audience. But as the person who is implemented, or as the company who's implementing the study, it's critical that if there are important implications, that those are communicated to the funder, even by phone. If something alarming or something that has implications comes up, it is really the responsibility of the researcher to communicate those along, even if it does not fall within the aspect of the report. And that being a very serious note, I would like to move along to a little bit lighter poll. So, if monitoring was performed and a report was prepared, but nobody read it, did the study actually happen? And this is more of an opinion piece. So I'll pause and let people pick which one they think feels the best.
All right, we've people are starting to weigh in here. Give them a few more seconds. We've got about 25% of the audience voting right now. All right, so we're at about 50%, and C is actually the most selected answer with 44%, followed by A, 31%, and then the others have 10% or less.
So again, you know, this is more of a philosophical question, a tongue-in-cheek, but I think it emphasizes a number of points. First of which is really how important was this monitoring if no one was planning on reading the report. So think about that, because the monitoring costs some money. So if it was, you know, for no particular reason, then perhaps that could have been a wasted opportunity. Another thing is that, as I mentioned, it's the responsibility of the study implementer to write a report that is going to be of interest and of quality to be read, and to just think about what are those questions that the study is designed to answer. And if the answer to the question doesn't really matter, such that you didn't read the report, then perhaps the study didn't need to be implemented to begin with. So I guess I would like to pass it along to Goni.
Thank you, Julia. Thank you for having me today. And I wanted to continue to talk about some of the considerations when reviewing and comparing reports. One of the main important considerations, in my opinion, is looking at the report and seeing which fatality estimator was used. So as new and improved fatality estimators come out, I think it's important to note that the point estimate and the fatality estimates may not be easily comparable. So they're not necessarily comparing apples to apples. In a study that we completed, we actually used the Genist versus Housekeeping versus Schoenfeld estimator to do that exact comparison and see how the different point estimates and confidence interval compared. And in that example, Genist ended up being the estimator with the highest point estimate, followed by Housekeeping, and then followed by Schoenfeld. However, the confidence intervals for all three estimators overlapped. Talking to other industry folks, I've heard that at times have seen different results. So they may not have necessarily seen Genist as being the highest point estimate. So again, the point is that we need to be careful as reviewers and as agencies when we are looking at reports and comparing estimators, and keeping in mind that, again, the comparison may not be apples to apples. In my experience, I think another factor that greatly affects estimates is the area correction. It seems that searcher efficiency, carcass persistence, the amount of area searched, at least the methods for calculating those variables is somewhat standardized, but the methods that you use for calculating the area correction, and even the restrictions and the assumptions that you put, even if you are using the same methods, can have a great impact on estimates. So when looking at reports, we need to be looking at not only which fatality estimator that we used, but also what factors and assumptions were used for that estimator. As far as reporting, I would say that it is a gift and a challenge to try to devise a report that's detailed enough and has that sweet spot of enough details. Reports pretty much should be detailed enough so that the study can be replicated, and we do have information where it can make it easier to compare reports. But at the same time, the report needs to be as succinct as possible. Time for reviewers and agencies, as you guys know, is limited. So it's probably not necessary to list every interesting trend that we see in a report. The level of detail for a report should really be tied, like Julia and Manuela mentioned, to the objectives of that compliance. So listing out those details where you answer those questions for your objectives and compliance. And I also think that it's important in reports to include the history and paint a picture of the project and the region. So at times I see that a lot of reports don't include communications that you may have had with agencies related to the study, what minimization strategies you used, how many years of operation the project has been under. So if, again, those details are included, reports can be more standardized, easily compared between years, and tell an evolving story of that project and of that region. Next slide, please. So next, I want to talk about evidence of absence, or EOA. Like Manuela mentioned, this is a take estimate for a single species, usually used for incidental take permits. It's a way that you can standardize your compliance requirements. And as Manuela mentioned, it's also a way that you can monitor both the short and the long-term take of permitted species for the lifetime of the permit or the lifetime of the project, whichever comes first. However, some of the challenges with EOA is that determining that you did not have take can be really challenging with low monitoring, especially when you don't have any of the permitted species on hand. So again, with EOA, you're trying to detect a rare event, and determining that that rare event didn't happen at times requires a lot of monitoring. On the other end of the spectrum, I know we heard recently from agencies on the siting conference that industry should consider doing compliance or getting incidental take permits for migratory tree bats, such as the hoary bat. And the moment that I heard that, I thought, how will EOA behave if the permitted species is not rare? So if you have a species like the hoary bat, where you have perhaps lots of take at your project, and that take varies widely from year to year, how do you devise a permit and use EOA for the permitted take of that species? And is EOA the right tool? I'd actually love to hear Manuela's perspective on this. Some other challenges with EOA is, again, we tend to think of it as, in my experience, I work a lot with the Indiana bats. We tend to think of it as the take estimate for the Indiana bat, but really it's the take estimate for a bat. EOA does not take into account the biology or species-specific info, especially for rare events such as the Indiana bat, where we don't have a lot of information about that species. So we're really using all bats as the proxy to make assumption about that species. So in my opinion, even though EOA is the best available estimator that we have, and it should be the primary tool to use for compliance, I think it could be useful to figure out other estimators or other tools that you can use, and preferably ones that do use species-specific or biological specific information to compare those results to EOA. So one of those methods that I'm aware of is the species composition, which is a really crude analysis, but again, it is a way that takes into account some of the biology of the species, and I'm not sure if there's others out there. Next slide, please. So lastly, I wanted to talk to you about G. The advantages of G, or the detection probability that's related to EOA, is that it's a way that it can standardize monitoring requirements for incidental take permits. It can also be, or it should be, project specific if you do have project specific data. And whoever devises the monitoring using G does have some flexibility of how that monitoring is implemented based on G. The challenges of G, of course, in reaching a higher G are cost. And the cost of G varies widely by regions, seasons, and projects. In terms of regions, my experience is mainly in the Midwest, where you have to do crop clearing in order to get a reasonable G or to get a higher G. and that crop clearing can be really expensive. So to reach a G of, for example, 0.2 in the Midwest can be a lot more expensive than reaching that same G, let's say out west or out in the grasslands type of habitat. In addition, seasonality can impact G. So the risky periods for bats in the Midwest is generally summer and fall, and those coincide with the seasons where crops are the tallest and require clearing. So doing more intensive monitoring during those seasons is obviously more expensive. And then lastly, implementing G by project can also vary in terms of costs, because you may need to do different size of monitoring depending on, or different types of monitoring depending on the size of the project, the size of the turbines for that project, how many participating landowners you may have, the size of your plots that you can allow for, and even the size of the gravel areas or roads and paths that you can search. And that relationship of G and cost is not necessarily linear. I would say it's more exponential, that cost tends to get higher the higher the G that you have to reach. In my experience, it seems like with each project, you tend to have an optimal G, or you tend to reach G to a certain point fairly easily, and then to increase G after that can be greatly expensive, because once you max out the number of your landowners and the number of turbines that you're searching, increasing sometimes the size of the plot or searching out further will not necessarily get you a higher G depending on the area correction. And similarly, increasing the search frequency, if you have a specific carcass persistence, may not again get you that same increment of G. So what I'm trying to say is that in my experience, I've seen that a lot of times increasing G from, let's say, 0.15 to 0.2 is somewhat expensive, and then going from 2 to 2.5 can be a lot more expensive. The last thing that I want to mention is that we have to keep in mind that G is a goal and not a guarantee. So we design a study with G in mind, but we have no control over what happens in the field during that study. I mean, we have no control over participating landowners and what they want to do with their land, whether that land is flooded. Many variables can lead to, or even things that are not necessarily human related, searcher efficiency, carcass persistence, all those things can be different than when you're expecting them to be at the beginning of the study. So I think that just like with estimates, it is best practice to include a confidence interval around G and have some flexibility, especially for compliance. I don't think that compliance should be tied to an exact G, because again, we have no guarantee of hitting that G and no control over hitting that G depending on how the study happens. So with that, I conclude my presentation, and I'd be happy to take any questions. Thank you.
Thanks, Goni, and thanks, Julie and Manuela, for the presentation. So we have about 25 minutes for Q&A. And we do have a couple of questions rolling in, and I have a couple of questions that we can start off with as the audience formulates additional questions. Julie and Goni, maybe from your perspectives, aside from the report, what else do you do to follow up or to communicate results, whether it's with an industry partner or with agencies, to ensure that that you've communicated the results of the study?
Julie, you want to go first, or you want me to go first?
Yeah, I mean, I would say one of the best ways is to have a conference call. So submit the report, give everyone a chance to take a look at it, and then, you know, host a call where the report can be reviewed together and the pertinent questions can be discussed.
And I would say on my end, again, no one likes surprises. I expect consultants to call me the minute that they find something that can affect compliance, and I in turn do the same with agencies because they don't also want to see surprises. I mean, especially if the report is related to some kind of compliance where you have to change your adaptive management or what you're monitoring or how you're doing this monitoring. Those things take a while to get rolling. So we want to hear as quickly as possible and get that information to the agencies as quickly as possible and start making those decisions.
Okay, great.
I would say, and that's one of the avenues that electronic data collection has really increased our abilities to do that. I mean, it's almost real time where, you know, the agencies can have all of the relevant information to answer their forms and their questions within a very short period of time from when it's actually found and then, you know, communicated to the site and onward. So that's been a great advance.
Right. That's great, and that it points to the need to communicate often throughout the study so that everyone stays on the same page. Manuela, you referenced the report by with Paul Robbie as the lead author. Is that out now or is it forthcoming?
It is. It has been submitted to AWWI, who commissioned it, and I don't know if they've released it or not. Dan and I are planning on writing a kind of a more formal USGS product that can be cited rather than just a report. It's a little bit carries a little bit more weight, and we would still be writing that with Paul and Jared, and but that's probably going to come out maybe towards the end of the year.
Okay, and you're also working on a module in addition to the GenS software, which is related to density weighted proportions and calculating the DWP. Can you update us on the status of that?
Yeah, that should be going out for review probably next week. This is what Goni referred to as area correction. We call it density weighted proportion. It's all about trying to get a handle on what fraction of the carcasses that were killed would land within the areas that you search. And as she pointed out correctly, it can be quite variable from site to site and from who's calculating it or trying to get a good estimate of it. It's a pretty tough thing to estimate. It's hard to get enough data, but yeah, that module is coming out hopefully for review in the next week or so. And then by the end of November, it'll be out in public as a R program.
Great. Okay, here is a question from the audience. In your experience, and this is for all of you, if you receive a report that doesn't meet your expectations, what actions have you taken kind of after the fact, after you've received the report, and what would you recommend in the future so that something like that wouldn't happen again?
Oh, maybe I'll start. I think that tends to happen from time to time. I think the best way to deal with it is to have a conversation with that consultant and try to figure out where the mark was missed and what needs to be included in the report. Honestly, I feel like a lot of time it's a miscommunication, especially when you don't work with consultants a lot. So yeah, with with consultants that we do work a lot, we actually take a lot of time to develop templates and kind of set those expectations for that exact reason, just because it can be so time consuming when you receive something that you didn't expect. And now you kind of have to start changing everything from scratch.
Okay, yeah. And
I would say one of the things so we are sometimes asked to review reports prepared by other consultants that are maybe they're quite old or whatever, and we will often, the client has asked us to provide feedback, and so we will often have a conversation really with okay, well, why is this missing from this report? Is this not something that you requested? And we would say, for future studies, these are components that you should request your contractor to include, because a lot of the clients are guided by what the consultant says they need. That's why they're relying on consultants. So I think there's sort of that responsibility there. But then also consultants might have opinions like, well, these are things you should include. And the client said, no, I don't want that. Don't put that in there. So there's a balance. And again, communication is key. And of course, there's that saying that the greatest myth about communication is that it actually happens. So, having that conversation during the RFP process and during sort of the kickoff to make sure, like, okay, this is what we're expecting to see for our report, have those expectations made very clear at the beginning.
Okay. Manuela, on one of your slides, you mentioned some challenges with using a national average for searcher efficiency and carcass persistence. What are your thoughts on if you collect that data in the first year of a multi-year study at the same site and using that first year data for subsequent years rather than collecting it each year?
I think that's something that needs to be answered with a biologist's hat on and not a statistician's hat on. If you have reason to believe as a biologist that the carcass, the scavenger population hasn't changed, and that your search process hasn't changed radically, you haven't changed crew, the people are about the same, or the dogs are the same, then it might be justifiable to use past estimates for current projects. But it's not, I mean, statistically, I can't tell you whether it's good or not. It's a biological and an inferential question.
Okay. Goni or Julia, any follow-up or thoughts on your end about using your experience maybe with using 1 year of data for subsequent years?
So I guess that I would just mention that that's an approach that's been proposed as a cost-effective strategy for long-term permits, sort of recognizing that the carcass persistence and search efficiency trials are an additional cost. And for example, if you've got an eagle take permit and that carcasses that you're putting out there can be perceived as bait for eagles, that's something that you're trying to minimize. So it's a balance of trade-offs. And I agree that you can go in with that being your approach, but then if you have a boom in like the local coyote population partway through, then you need to ask yourself, well, that data we collected 3 years ago, do we think that's really representative of our site conditions now? And if it isn't, you're doing yourself a disservice by not measuring that changed carcass persistence.
I think it'd be great if eventually we can get to a point where we have enough regional data to come up with those estimates. Honestly, from my experience, it seems like those estimates are project specific, but somewhat similar in a region. We do tend to have outliers from time to time. So if we do have enough data to come up with a regional estimate, that's great. And then maybe you can do something like spot check that estimate every few years, just in case conditions at your site may have changed.
Always keeping in mind that there are certain factors that we have identified pretty well now that often have an effect. And so, yeah, it might be regional, but regional for a visibility class that's relatively well defined and consistently defined across the region as being easy versus moderate versus difficult, for size classes that are consistent, as Julia was saying. So those kinds of things still need to be kept in mind. Rather, my objection was to a single searcher efficiency that represents an average across all of those factors, which is going to get you into nothing but trouble.
Okay, so here is put your futurist hat on. You know, there are a bunch of technologies being explored, various stages of development, that might be used in lieu of our standard post-construction mortality monitoring, or, you know, in the offshore environment where we can't do PCMs. So one, have you had any experience in in testing some of these technologies and how they compare to post-construction monitoring, such as use of cameras, vibration sensors, or, you know, some sort of strike detector? Or if you haven't, what are your thoughts on how we might use those or test those and see how they might relate to post-construction monitoring?
I think it'd be great if we can get to a point where we can utilize technology instead of people. I think it can be cost effective, and if it can be cost effective and easily implementable, the industry would be all about it. My experience was at one project where we did use a camera-based system to test detection exactly. The system was still in its infancy, just piloting, and it turned out that the modeling that you need to pick out carcasses from the background from those cameras can be really, really complicated, and you need to continue to work on refining that. It tended to be more difficult in plots instead of gravel areas. So in plots that were more similar in color to bats and maybe more variable in their vegetation, it seemed like the camera system was struggling more with that. So we didn't get a lot of great results from that study, but I think that studies like that and technologies like that need to be continue to be tested, and it would be great to have that as a tool available.
Yeah, I have not personally worked on a study that's had some of these other technologies implemented, and I think it's largely because many of them are still sort of working the kinks out of the algorithms that they're using to either detect the thud with the wind components, the wind turbine components, or the carcass on the ground. I think just myself, I think it seems the most logical and cost effective would be detecting the impacts with the wind turbine, and then you not having to control the ground surface characteristics, because if you are having to pay for lost crops in order for those camera systems to work, then you've lost a lot of your cost efficiency. So I think there's some great promise there, but we're all still kind of waiting for the technology to be more cost effective. And it's alarming to think about, you know, $150,000 or $300,000 a year of people searching for dead stuff under turbines being the cheap option. And I know the industry as a whole would love to see that that funding doing something that actually lends itself to conservation as opposed to just counting dead stuff.
Yeah, I've had a little bit of experience in working with Oregon State University to try and do kind of a combination of thunk detectors and location detectors. So I think a lot of it has to do with species. I can conceive of a a system that detects a collision and would be able to distinguish between the collision with an eagle or something very large, maybe it's a turkey vulture, but it's something very large, versus, you know, a hummingbird or a bat. So it might be a combination of efficiency in the searching process. You detect a thunk of something big, you have cameras pointed along the blade that give you just kind of a sense of where the blade was when that occurred, and so then you can be very efficient in where you go look for it. And then you go look and see whether it was a turkey vulture or an eagle. So instead of doing, you know, a search every week or every 2 weeks of all these areas, you only search when you think that there's something to search for. For bats, that might not work so well. There's a lot of things out there that could get hit, and it would sound like an Indiana bat, but I think there's a lot of opportunity, at least for species specific, that we're interested in.
And there's it's a great strategy, and we've been discussing, you know, some of this imagery, thermal or drone searching, where then you have somebody come and check. But part of the problem, of course, is that if the bat fatalities are harder to detect the thump, and they're also harder to find, and they can often disappear, like the ones that disappear quickly, like disappear often the night that they occur. So unless you have somebody who's going to go walk out to a turbine at 2 in the morning, you know, that still allows for a lot of data loss.
Right.
Okay. So a question from the audience. It was mentioned that integrated bias trials can lead to estimates that are biased high. In your experience, what is the potential magnitude of this bias for a typical project?
So first of all, I don't think the direction of the bias is necessarily predictable. It's all about that combination of how the interaction of the detection probabilities in the different categories that you are kind of merging over relative to the arrival rates in each of those categories. So it could go either direction. It could, by chance, be spot on, but it would just be chance. And so I can't even begin to try and estimate what the magnitude would be. It's all about what you're merging over or combining, and what the relative arrival rates are. So I didn't mean to imply that it was always going to be an overestimate. It could easily be an underestimate under other conditions.
Okay. So there are some challenges in communicating results. There are, you know, the quality of the report. We've got different estimators used over time, some confidentiality. You know, what do you think going forward is the best way to communicate results from a project, from a region, you know, and or how do we overcome some of these challenges so that we're all working on the best available information to make the right decisions?
So I guess I mean, Manuela was working with AWWI, and I'm also working with them on a research project looking into potential effects of turbine size on bird and bat mortality. And the data that's been assembled in the AWWI's information center is extremely powerful. And I know that they're always reaching out to other wind operators to have the studies go into that. And I think the confidentiality, they've set up protections so that those concerns have been addressed. And Canada also has a comparable database for studies in their country. But you know, leveraging having that be this controlled set, confidentiality has been addressed, and using that information to learn from each other and try to look at, you know, population level effects or the big picture questions, I think is, you know, ultimately we all want to get there, so that the burden of, well, what's your one facility's impact? What's that one facility's impact? We don't have to be answering that question. We can be looking at it as a whole.
Yeah, I completely agree with that. And that way, someone from AWWI can look at those different variables that vary and can be informed enough to see if different estimates should be comparable, different results should be comparable. How do we make them apples to apples? How do we come up with an estimate that's having the least amount of bias and comparison challenges?
I think, yeah, going forward, I guess standardization of the way that we collect data. One of the problems that AWWI has is that the data that have been submitted may include, for example, it may include raw data for calculating searcher efficiency in various different categories. Or it may just give you an average searcher efficiency for all categories, which would, in my mind, be a mistake to use. So if we can make sure that people are submitting their data in such a way that it's consistent across the different studies, that would go a long ways. One of the advantages to using GenEst or something like GenEst is that the structure of the data is pretty set. So you know that you have to submit this kind of data for searcher efficiency, this kind for carcass persistence, this kind for the found carcasses. It makes it really easy for someone to submit those files to AWWI, and from there, whoever has permission to use them can use them easily.
Okay, great. Thank you. I think we're just about out of time, so I want to thank the three of you for your willingness to be a part of our webinar series. Just a reminder that we have 3 more of this 9-part webinar series. If you have any questions, you can email Shana or Pasha at the email addresses listed here. You can go to the Tethys website and register for these webinars. And with that, thanks to everyone who attended today, and we'll hopefully see you next Thursday for the webinar 7.
Thank you.
Bye, thank you.